right? Point charges of plus q and minus q are placed at q and y respectively. When another charge is placed at z, the resultant force on the charge at x is 0, right? So you keep an unknown charge at z. Let's call it capital Q, right? So when you do that, when you go and keep positive, or rather, we don't know, unknown charge at Q, at Z, the force at X becomes 0, right? Distance XY equals to distance YZ. So these two distances are equal. So let's call it R and R. Right. Which of the following is the charge placed at Z? Right. Now, since we are talking about forces, guys, we obviously will have to use Coulomb's law in this case. Now, if the force is 0 due to two charges, right? Due to one charge, the force cannot be 0. There should be a resultant force. But if the force is 0 due to these two charges, that means the resultant force is, in other words, the resultant force is 0, right? So the forces are at equilibrium. So there should be two forces acting on Q, which are opposite and equal in that case, right? So obviously, the force between small q and small minus q should be attraction. F. And obviously the other force should be repulsion. Equal. Because the forces are equal and opposite, then only the resultant becomes 0. Right? So now at the moment we have used the information that are given to us in the question. Right? So now we'll write these two forces. Right. So this force would be what? K Q into Q over R squared. Right. What about this force? K simple Q into capital Q over the distance between two charges. Simple Q and capital Q. R plus R, 2R, 2R squared. Right, so these two are equal. We'll equate them. KQQ 4R squared equals to K simple Q into simple Q over R squared. Right. Now we can eliminate cancel the ones which are equal. R squared can be cancelled out. Right. These we have introduced into the question. And one Q can be cancelled out as well. Right. So what is left now? So the Q is left here. 4 is left here. And Q. So capital Q equals to 4Q. That is the answer, right? So our answer is D. F. So let me mark this. So you have two charges plus Q and positive 2Q. The force between them is F. So it should be repulsion, right? Because they are like charges. When the charges are increased to plus 2Q and plus 4Q, and the distance is increased to 2D, the initial distance is D, and now the distance is increased to 2d, and the charges have become plus 2q and plus 4q. Which of the following gives a new force? Right. So it's also going to be repulsion between two like charges. So let's call it F1. F1 force on both the charges. They are equal and opposite. Right. So we'll write our Coulomb's equation for the first scenario. So that is F equals to, we'll use K, right? Coulomb's constant, K, Q into 2Q. Those are the two charges divided by R squared. So distance is D, so D squared. So that's the first one. And the second one, F1, K, one charge is 2Q and the other one is 4Q. Over distance, 2D squared. Right, so let's rearrange this equation. So we get 2 into 4, 8, 8K, Q squared, and you have 4D squared at the denominator. Right. Now we need to express F1 using F, right? So F is 2K Q squared over D, D squared. Right. So 8 divided by 4 is what? 2K Q squared D squared. Oh my gosh. Both are the same, right? Both are the same. So what's the answer? C. Of 2 microcoulomb and 3 microcoulomb are placed 1.2 meters apart as shown. Okay, and there is a point X in between 2 microcoulomb and 3 microcoulomb. The point X is in between them. The point X is 0.4 meters from 2 microcoulomb charge and 0.8 meters away from 3 microcoulomb charge. What is the electric field strength at the point labeled X? Right. So what is the question? Our question is to find the electric field strength at X. Electric field strength by point charges. Right. How do we find electric field strength? Let's go by the definition. Electric field strength is the force on +1 Coulomb charge. Force on positive unit charge. Remember, that is the key. Force on positive unit charge, +1 Coulomb charge. So if you calculate the force on +1 Coulomb charge, you will get the electric field strength. Understand? So then what you can do is, remember this, right? Now this is the method you should use. You go and keep +1 Coulomb charge at X. Right? So what are we going to keep at X? +1 Coulomb charge. And then you calculate the force on +1 Coulomb charge, right? But then, now hypothetically, we have +1 Coulomb charge at X because we want to calculate the force on it, and that force should be equal to electric field strength, as we know, according to the definition. Now, there are two charges. There are two charges here, 2 microcoulomb and 3 microcoulomb. 2 microcoulomb exerts on a force on +1 Coulomb charge. Let's write it here. Right. So 2 microcoulomb exerts a force on +1 Coulomb charge. Let's call it F2 from 2 microcoulomb, right? So if they are positive charges, 2 microcoulomb should repel +1 Coulomb. And then we have 3 microcoulomb also, we can't forget that, because it also helps to, or contributes to, create the electric field at X. So we got to consider its contribution. So 3 microcoulomb charge being positive, it exerts a repulsion on +1 Coulomb charge. So we'll call it F3 from 3 microcoulomb, 3, F3. Right. So these two forces are opposite to each other. Okay. Right. Now we can use our Coulomb's law, or rather the equation E equals 1/4 pi epsilon naught Q over R squared to find the electric field strength, right? Now I'm going to make it E2 and E3 because the force on positive unit charge can be called the electric field strength, right? So then what is E2? Electric field strength from 2 microcoulomb. That is 4 pi epsilon naught Q. Charge of this particular charge is 2 microcoulomb, 2 into 10 to the power minus 6, the distance between the charge and the particular point, 0.4 meters. So R squared, 0.4 squared. In the same way, we can find E3. Electric field due to 3 microcoulomb charge, 1/4 pi epsilon naught into the charge. Charge is 3 into 10 to the power minus 6, since it's microcoulombs. And the distance between X and the charge, the point X and the charge, is 0.8. 0.8 squared, right? Now you have E2 and E3. They are opposite. So if you want to find the resultant electric field strength, you want to get the difference of them, right? So any answer which has the addition should be wrong. So A and C are out. So either it should be B or D. B or D. This is a MCQ question, right? If you're going to do the calculations, it takes time. And we'll see whether we can figure out the answer without doing a calculation, right? So 2 and 4, they should be together. 3 and 0.8, they should be together. Take D. 2 and 8 are together. So that's wrong. So the answer is this, right? So if you calculate, this should be higher. E2 should be higher if you calculate. but they have made it easier for us to get the answer just by comparing, right? You don't have to do the final calculation, right?